All right, last day of Unit 7, parts of similar triangles. Today's review is going to go pretty quick. These problems that you're going to have to do for homework are not that hard, so get through this one, and then we're done with Unit 7. First thing for review, altitudes in triangles. An altitude is when I start at one vertex, and then I draw a line perpendicular to the opposite side. Okay, so there's one altitude. And all triangles really have three altitudes. I could do it from there. I could do it from another point. I just have to make sure, or I would have to make sure that whatever line I draw is perpendicular to the opposite side, right? Meets the opposite side at a 90-degree angle. So like I said, there's every triangle has three altitudes that I could draw in there. Angle bisectors, when I bisect something, that just means I cut it in half. So every triangle is going to have three angle bisectors as well. If this angle down here is 46 degrees and I bisect it, that means I'm splitting it so that there's now two 23-degree angles. Right? If I do the same thing with the angle on top, let's say this angle starts out as 54 degrees. If I split it in half, it's going to make two 27-degree angles. Last one, if this angle over here is 80 degrees and I bisect it, that means I'm splitting it into two 40-degree angles. So just like with altitudes, all triangles have three angle bisectors as well. Last one, medians. What a median is, that means if I find the midpoint of one side, so like let's say that's 4 and 4, and then I draw a straight line from that midpoint to the opposite vertex, that is a median. And so just like with altitudes and angle bisectors, all triangles have three medians. And this one look like this. So altitudes, angle bisectors, and medians. Okay, three new theorems for today. First one says, if two triangles are similar, and that's kind of what I've written in right here. In other words, the ratio between corresponding sides is the same. So AB and DE, that ratio, let's just put some numbers in there. If this is 20 and this is 10, then the ratio between all corresponding sides would have to be 2, right? Because AB is twice as long as DE. So that would mean that if AC is 14, side DF would have to be 7. And it means if BC is, 16, EF would have to be 8. Okay, so this says if two triangles are similar, the lengths of their corresponding altitudes have the same proportion as the lengths of the corresponding sides. So all that's saying is, if I have two triangles that are similar, and then I go in and I start drawing altitudes in each one, corresponding altitudes, the ratio between these two altitudes is going to be the same as the ratio between all the other corresponding sides. So if I call this point G and this point H, the ratio between AG and DH is going to be the same as the ratio between all three of the sides. Next one, if two triangles are similar, then the lengths of their corresponding angle bisectors have the same proportion as the length of the corresponding sides. So same thing here. If this side is 20 and this side is 10, and I assume that the ratio between the other pairs of corresponding sides is also 2, then the ratio between this angle bisector, call that BG, would be equal to the ratio between BG and, let's call this EH. again, the ratio between AB and DE is going to be the same as the ratio between BG and EH. And that's if we're dealing with an angle bisector. I should have sort of marked that down here. All right, last one, similar to the other two. But now we're dealing with medians. So once again, if I draw in a median here, let's say from A down to the midpoint of BC, and I call that G, and then I do the same thing on triangle DEF. I draw a median from D to the midpoint of EF, and I call that H. If AB is 30 and DE is 10, what's the ratio between those two? It would be 30 divided by 10, which is 3. What that would mean is that if AG is 18, DH would be 6. Right? I'm just using numbers as an example. Basically, if I want to just write it out, I would say that the ratio between AB and DE, corresponding sides, is the same as the ratio between the two medians that I've drawn. First example problem, and this will be like homework problem number 8. It says that triangles ABC, just so we're clear about which triangles it's talking about, ABC is similar to FDG. And so you can see that they're not turned the same way, even though it sort of looks like it. If I actually turned FDG so that it would look like ABC, I would have to sort of flip it up and then kind of reflect it. Anyway, ABC is similar to FDG. It wants me to find the value of X. X is an angle bisector, as is this QF here, which is 8. And so the ratio between the angle bisector on the big triangle, which is AP, and the angle bisector on the small triangle, which is QF, has to be the same as the ratio between corresponding sides on the triangle. And so the two sides that I have are AB on the big triangle and DF on the small triangle. How do I know if those two are corresponding? Well, if I look at the way that the triangles were described in the problem, I can see that they are, because they're both points are in the same position in both triangle labels, AB and DF, or FD. So plug in what I know and then solve for what I don't. I know AP is just going to be X for now. QF over here is 8. AB is 15. And DF is 12. So I'm going to cross multiply. 8 times 15 on the right. 12 times X on the left. 8 times 15 is 120 equals 12x. Divide both sides by 12, and x comes out to be 10. In other words, this angle bisector here would be 10 units long. Example 2 deals with altitudes. The way I know it's an altitude is because it's a line going from one vertex to the opposite side, and it's perpendicular to that opposite side. So again, I'm going to assume these two triangles are similar. I know one of the altitudes, I don't know the other altitude. But what I do know is that the ratio between the altitude on the big triangle, which is MP, and the altitude on the small triangle, which is YQ, has to be equal to corresponding sides on the two triangles. So KM on the big triangle and YX on the small triangle. So as always, I'm going to plug in what I know and solve for what I don't. MP is 16, YQ is what I don't know, so I'm going to leave that as an X. KM is 20, and YX is 15. So again, we're going to cross multiply. X times 20, and then 15 times 16. So X times 20 is going to be over here, x times 20 I know is just 20x. 15 times 16 on the other side. All right, well, it's 15 times 16. That is going to be 240 equals 20x divided by 20. X is 12. Okay, now I have medians. Before I do anything, I'm going to make sure I have the kind of information that I want to solve the problem. So what it's telling me right here is just that SP is X. And because it has that slash here and here, I know this would also be an X. So I'm just going to write over here that SR is 2X, right? It's just X plus X. Same thing down here on the corresponding side of the smaller triangle. It's telling me that UQ is 3. I have the slashes, so I would know that QV is also 3, meaning that UV would be 6. All right. That's just going to make it easier to solve this one. Okay, I'm dealing now with medians, but the rules that I used on the last two examples hold. In other words, the ratio between the triangle center is the same as the ratio between corresponding sides on the two triangles. So what do I have and what do I don't? Well, let me write out the proportion first. What I just got done saying is that the median on the big triangle, 13.5, and its ratio with the median on the small triangle, which is 9, has to be the same as the ratio between corresponding sides on the triangle. And the only two sides that I know on the triangle are 2x and 6. So 2x is the side on the big triangle, SR. 6 is the side that I know on the smaller triangle. Okay. Cross multiply would mean I would take 6 times 13.5, 9 times 2x. So 13.5 times 6 on one side of the equation, and then 9 times 2x on the other side. 13.5 times 6, I'm feeling lazy, so I'm going to use the calculator, is 81. 9 times 2x is just 18x. Divide both sides by 18. X is going to turn out to be 4.5. All right, we have one more theorem to learn in Unit 7. And it says that an angle bisector in a triangle separates the opposite side into two segments that have the same proportion as the other two sides. Here's what that actually looks like. It means if I take angle B here and I bisect it with a line. Bisect angle B. So if angle B was 50 degrees, I would be cutting it into two 25-degree angles. Let's say I do that. What it does is it cuts AC. It cuts that line into two segments. So two segments of potentially different lengths that have the same proportion between them. So the proportion between AD and DC is the same as the proportion between the two other sides. And by other sides, what I mean is it's going to be side AB and then side BC. So how can we use that in a problem? Well, okay, what do we have here? I have an angle bisector, which is cut line segment SQ into two parts. One of those parts right here is X. I'm not told what this part is, but I can sort of use an expression to represent it. If this whole thing is 18 and this part of it is X, then this part right here is 18 minus whatever X is. And you'll see why I'm doing that here in a minute. And then I have these two other sides. So what I said was when I bisect an angle, I break that line that it intersects into two proportional parts. So ST is one of those parts, QT is the other part. The ratio between those two new segments I've created is the same as the ratio between these other two sides, SR and QR. All right? So ST is going to be in the same position as SR, and QR is going to be in the same position as QT. Okay, so the ratio between ST and QT right here has to be the same as the ratio between SR and QR. All right, so let's plug in what we know and solve for what we don't. ST, that's that one that I'm calling 18 minus X. QT is the one that they gave us as X. SR is 14 and QR is 6. Okay, so same as always, when I have a situation like this, I'm going to cross multiply. On the left, I'm going to have 6 times this whole thing. 6 times 18 minus X. And on the right, I'm going to have X times 14, which is just 14X. What do I have to do when I have a number outside of some stuff inside of the parentheses? I have to distribute. So I'm going to have 6 times 18, which, if my math is right, is 108, minus 6 times X, or plus 6 times negative X. Either way, it's negative 6X, still equal to 14X. Now I just solve the equation. I'm going to add 6X to both sides. Those go away. I have 108 equal to 14X plus 6X, which is 20X. Divide both sides by 20, and X is going to be 5.4. Okay, last example, the last part of Unit 7. Then you'll be ready to work on your homework when you come in the next day. Okay, I have an angle bisector right here. And so the two line segments that it creates have to be proportional to the other two sides. So what would that actually look like? Well, 9x minus 2, the proportion between it and 6x plus 2 is going to have to be equal to this side, which is 10, over this new segment, which is 8. Okay, so I don't do anything different than I've been doing. Whenever I have fractions on either side of an equation, I cross multiply. And so on the right side, I'm going to have 10 times 6x plus 2. Other side of the equal sign, I'm going to have 8 times 9x minus 2. And now I just have some distribution to do. 8 times 9x and 8 times negative 2. Well, 8 times 9x is going to be 72x. 8 times negative 2 is negative 16. 10 times 6x is 60x. 10 times 2 is 20. And now I'm just going to combine like terms. I have a couple of options of how to do that. I'm just going to start by adding 16 to both sides to get the numbers off of the left side of the equation. So those are going to go away. What that leaves me with is 72x being equal to 60. X plus 20 plus 16, which is 36. Now, because I've moved numbers off the left side, what it means I'm doing is I'm trying to put all the X terms over here. I want X terms on the left, no numbers. On the right side, I just want numbers, so I don't want this 60X anymore. I subtract it from both sides, it goes away. 72X minus 60X leaves me with 12X being equal to 36. Divide both sides by 12. X is just 3.